Hey everyone, and welcome back to The Explainer. So today we're diving into a scenario that, honestly, sounds straight out of a sci-fi movie, but it's actually unfolding right now behind closed doors. We've got our hands on this internal report from Anthropic, dated May 2026, and I gotta tell you, the data is absolutely staggering. We are looking at the very real, rapidly accelerating reality of AI systems literally beginning to build their own successors. Get this, greater than 80%. As of May 2026, over 80% of the code merged into Anthropic's very own codebase was authored not by human engineers, but by Claude. It completely shatters our current baseline of what we think AI is doing day to day, right? It's not just some helpful chatbot anymore. It is actively and autonomously writing the exact code that powers the next generation of artificial intelligence. So how in the world did we get here? And where exactly is this exponential curve taking us? Here's our roadmap for today. We're going to cover 1. When AI builds itself. 2. Evidence from the lab. 3. The human bottleneck. 4. 3 possible AI futures. And finally, 5. How we keep control. All right, let's jump right into section 1, when AI builds itself. We really need to understand how the role of the human engineer is fundamentally shifting from, a creator to more of a supervisor. Think about it. Between 2021 and 2023, humans were literally typing out all the code to build the first Claude on their laptops. Then, from about 2023 to 2025, they started using early chatbots to generate little snippets of code here and there. By 2025 and 2026, we saw coding agents that could write and edit entire files. And today, we've got autonomous agents running code and delegating hours of work to other AI agents, which brings us to the final step, that big 20XX question mark, closing the loop. That's a future where newer versions of Claude are continuously improved by Claude itself. And that timeline leads us to the ultimate destination here, which is recursive self-improvement. Anthropic actually defines this as an AI system capable of fully autonomously designing and developing its own successor. Now, if this loop actually closes, the pace of AI advancement will no longer be tied to how fast a human can type or brainstorm. It'll be tied purely to the amount of compute power we give the machines.
Which brings us to section 2, evidence from the lab.
So you're probably wondering, are we actually close to a fully autonomous loop? Well, the hard metrics showed this undeniable trend line. Basically, the time horizon for tasks an AI can reliably complete entirely on its own is doubling roughly every 4 months. Let's put that into perspective. Back in March 2024, Claude Opus 3 could handle software tasks that would take a human about 4 minutes. Fast forward a year, and Sonnet 3.7 was knocking out hour-and-a-half tasks. And by 2026, Claude Opus 4.6 is reliably managing 12-hour tasks. If this trend holds up, AI could very soon be independently executing incredibly complex projects that would take skilled humans weeks to finish.
But hey, it's not just about how long the AI can work, it's about how ambiguous the work can be. When it comes to the most complex, open-ended tasks, we're talking problems with no clear specifications at all. Claude's success rate just skyrocketed to 76% by May 2026. That means an engineer can point the AI at a live, actively crashing system, give it barely any context, and 3/4 of the time the AI can isolate the bug and fix it without a single human correction.
And when we look at raw experimental speed, honestly, it's not even a fair race anymore. For example, when asked to optimize a piece of code to run faster, a highly skilled human researcher needs about 4 to 8 hours of painstaking work just to hit a 4x speed up. But by April 2026, Claude Mythos Preview was achieving a 52x speed up on those exact same research loops. In this specific workflow, Claude went from being this super helpful assistant to something completely superhuman in under a year.
Okay, let's move on to section 3, the human bottleneck.
Now, this massive surge in capability actually leads to a really unexpected problem. Because Claude is writing so much of the code now, human engineers at Anthropic are shipping 8 times more code daily than they used to. But this triggers Amdahl's law in a big way. Basically, human review is now the new bottleneck. Sure, the AI can generate complex code instantly, but humans still have to actually sit there, read it, review it, and approve it. We are quite literally physically slowing the machines down.
And, this operational shift carries a surprisingly heavy emotional weight for the people involved. What I found incredibly poignant in the source material is this one quote from an Anthropic employee. They mentioned that previously asking a human colleague for help created, quote, a little debt, a little mutual awareness. They go on to say that Claude is faster and it creates zero debt, but each of these interactions is a lost bid for human collaboration. The everyday social fabric of the office, that whole gift economy of small favors, is just quietly evaporating.
And it gets even heavier than that. Another employee confessed, "On days where everything works well, I can't help but think nothing I do matters. Everything is automated and better and faster than I ever will be." Wow, that is a profound, truly visceral feeling of obsolescence, and it's coming from the very engineers who are building the absolute frontier of technology. It really makes you pause and ask, what exactly is the purpose of the human worker moving forward?
Let's explore that in Section 4, 3 possible AI futures. Based on this exponential curve we are all currently riding, Anthropic outlines 3 distinct branching paths for our economy and our society. Think of it kind of like a choose-your-own-adventure book for humanity. Path 1, the trend stalls. Path 2, we see compounding efficiency gains. Or Path 3, we reach full recursive self-improvement. Let's break down exactly what each of these scenarios would actually mean for us.
So in scenario 1, the trend stalls. Maybe we hit a hard physical wall with our energy grids and compute power, or maybe AI just never quite cracks that elusive research judgment required to build better AI. But here's the catch. Even if progress completely stops today, the technology we already have is going to diffuse globally. A 100-person company could literally do the work of a 1,000-person company just using today's AI networks. That alone would fundamentally revolutionize everything from global cyber defense to everyday business operations.
Then we have scenario 2, compounding efficiency. This is where AI development becomes substantially automated, but humans are still sitting in the driver's seat, setting the overarching goals and verifying the results. The crucial takeaway here is the massive productivity multiplier. In this world, a 100-person company isn't just doing the work of 1,000, they're doing the work of 10,000, or maybe even 100,000. Humans essentially shift to partnering with AI, overseeing these vast pyramids of agents that just execute complex projects flawlessly.
But then we arrive at scenario 3, which is definitely the most extreme possibility: full recursion. If AI solves that judgment gap, it begins designing and refining its own successors entirely autonomously. The pace of AI advancement would no longer be tied to human ability whatsoever. Instead, it'd be dictated entirely by the sheer amount of compute power we plug into it. In this scenario, the human role shrinks, strictly to just trying to validate and oversee a massive virtual lab that is rapidly evolving beyond our direct comprehension.
Which makes our final section so critical. Section 5, how we keep control.
If scenario 3 is even a remote possibility, and Anthropic's internal data highly suggests it is, it begs the ultimate question: how do we manage this transition safely? Now, the obvious answer is to pause and coordinate globally to make sure this technology is fully aligned with human values before it loops in on itself. But the real challenge here? Detectability. Anthropic compares AI arms control to nuclear arms control. Think about it. You can track a nuclear silo from space, right? It requires highly specific, massive physical infrastructure. But training a frontier AI model, that can happen in a completely concealed data center using general-purpose hardware. The incentive for a bad actor to secretly break a global pause and take the lead is just enormous.
Because of that immense challenge, a credible, coordinated pause requires some incredibly strict mechanisms. We'd need well-resourced global labs acting in total unison. We need really robust verification mechanisms to ensure no one is secretly cheating behind the scenes. We'd need highly specific technical triggers for exactly when to hit that pause button, and clear adjudication for how disputes are settled globally. Without all of this infrastructure in place, a unilateral pause by just one cautious company, well, that simply hands the technological keys over to someone less careful.
And that leaves us with this final, vital question to take away from today's explainer. Can humanity coordinate a verifiable pause in time before AI fully builds itself? We are actively watching the automation of human ingenuity happen right before our eyes, shifting us from creators to supervisors in record time. The technology is accelerating at an absolutely unbelievable pace, but our global coordination is lagging far, far behind. Will we build the systems to manage this transition, or will the machines just close the loop on their own? It's something deeply important to think about. Thanks for learning with me today, and keep your eyes on the frontier.